So today we have an interesting geometrical problem. The details of the question is on the screen. So as you have read the question, you have come across this particular aim that you need to find the complete blue area. Okay. So now this one is a very easy geometrical problem. Anyone with a basic geometrical knowledge should be able to solve this. So let us utilize the each of the point that the question has given to us. This is the main thing to solve any geometrical problem. Look for the fact that the geometrical problem has given to you. So the first thing, why they have given this tangent point. So one can utilize it. Okay. So the best way to utilize the tangent point is to join the tangent point and the radius. So as O is the center, a line from O to this tangent point will act as the radius. Nice. Let me just make it clear over here. Yes. Okay. So yes, now it is good. So as it is a radius and that is a tangent point, the angle over there would simply turn out to be 90 degree, as it is basic theorem, or we can say the basic logic, that the tangent and the radius will meet at 90 degree. Okay. So now I forgot to mention, but this angle is also 90 degree. It was not given in the question, but as the diagram has been plotted, one may understand, and if you are unable to understand, sorry for that. But yes, this angle is 90 degrees over here. Nice. So this angle is 90 degree, and over there the top angle is 90 degree. Now look carefully in this particular two triangles. What you can observe? You can simply see that these two triangles are congruent to each other because they have a right angle equal, they have this hypotenuse equal, and what about the sides? So this is also the radius and this is also the radius. In the similar way, these two triangles are congruent to each other. Again, they both have a right angle, they both share the common hypotenuse, and they again have the sides equal, and that is the radius. Okay. Nice. So as these two triangles are congruent, the remaining parts of the triangle becomes equal. So now look, if that length is 2 square root of 3, so this length also becomes 2 square root of 3. And similarly over here, if this particular length is 3 square root of 3, this length over here becomes 3 square root of 3. Okay, nice. So this was done. Now what should be done next? So the next thing is, again, look carefully, as these two triangles were congruent to each other, the remaining angles would become equal, and hence we will have this angle is equals to A, so this angle also equals to A. Similarly, these two triangles were congruent. So if this is B, so again this is B. So now this complete line at at point O, as the complete line is a straight line, we can have the fact that A plus B is equals to 180 degree. Hence we'll have 2A plus 2B equals to 180 degree, resulting in the fact that A plus B is 90 degree. Now look carefully where the particular pattern of A plus B is forming. It is forming over here, this complete angle. So we have concluded a fact that this complete angle is equals to 90 degree. So if I just select this in red color, and I can just mark that yes, we have found that this angle is equals to 90 degree. Okay, we'll just keep that thing, and I will show you later how that is very important in this solution. Nice. Now as we are dealing with areas, let us mention here at point O we have done this. Now the radius let the radius be equals to x. So the length OA would be x, and similarly length OB equals to x. Now what I will do is I will drop a perpendicular from the point Q on this side of PB, I guess, yes. So from O to PB I will drop a straight line that is meeting at 90 degree. Nice. So now you can see that this particular rectangle, or we can not rectangle, the first thing that you should say is a quadrilateral. So this particular quadrilateral turns out to be a rectangle, because all the four angles are 90 degree. So in rectangle, opposite sides are equal. So first of all, the base complete length is 2x. So this will also be 2x because x plus x. And the other thing, that this length is 2 square root of 3. Hence we'll have that this length from here to here is 2 square root of 3. The complete length is 3 square root of 3. This means that this particular remaining length will turn out to be just square root of 3, subtracting the lengths. Nice. Now look at this top right angle triangle that has been formed over there. So the base we have is 2x, the height is square root of 3. What about the hypotenuse? So we have already deal with that in the starting of the solution. We have found its complete length as 2 square root of 3 from here to here, plus 3 square root of 3 from there to there. So nice, we will have this length as 5 square root of 3. So now simply applying the Pythagoras theorem, we can say that 2x the whole square plus root 3 the whole square turn out to be 5 square root of 3 the whole square. Therefore 4x square plus 3 is equals to 5 square 25, and 25 3 75. Hence we'll have 4x square is equals to what? 73 minus 75 minus 73, that's 72. X square will turn out to be 72 upon 4. and that's basically 18. So we have the value of x square. Should I need to find the value of x? No need. Again, look carefully over here. So now we have the not the accurate side of this particular semicircle, but yes, we have the squared value. Now let's talk about this blue area, final part of the solution. So look carefully. The area of semicircle. The area of semicircle over here is the area of the blue shaded region. AR means area, BSH means the blue shaded region. So area of the blue shaded region plus area 1. Now what's the area 1? So look carefully in this yellow color that I am doing. This is the area 1. Okay. Now, what is fascinating about this area number 1? The fascinating thing about this area number 1 is that it is having the central angle as equals to 90 degree, means it is a quarter circle. So to find its area, it's very easy. All we need is pi r square upon 4, and the value of r we already know. Okay. So now look over here. Let's substitute each of the value. Area of the semicircle is simply pi the radius square upon 2. Area of the blue shaded region is the thing that we need to find, plus area 1, it should be simply pi the radius square upon 4. Okay. Now as I told you, we don't need x because all we need is x square. So 18 pi upon 2 means 9 pi, and that is area of the blue shaded region, plus now over here we'll have 18 pi times 18 upon 4 means 9 pi upon 2. We'll do a simple subtraction, and hence we'll have this particular part, that area of the blue shaded region is 9 pi upon 9 pi minus 9 pi upon 2, resulting in 9 pi upon 2 unit square. So yes, this was the area of the blue shaded region. One may also think that as it's a semicircle, already a quarter circle, so the remaining addition should also be a quarter circle in that particular matter. But the main thing of this particular problem was to just find the radius, and instead of going this central angles, because as they are the sectors, we have that formula of area of the sector is theta pi r square upon 360. So one may use that, and for that they may need theta 1 and theta 2 of these two as separate, but yes, using this area 1 as 90 degree and subtracting is a smart solution, I think. And I think this is the shortest geometrical problem on this channel. And don't worry, we are not going to solve easy geometrical problems very often. Instead we'll do hard geometrical problems. But yes, for the channel growth, or for some viewers who are still learning, this may motivate them. Okay. Now, yes, the as I told you, the previous video was easy. This one is also easy, and the next one is not easy as this both, but yes, it's also on the easier side. So the beginners, be ready with your pen and paper, and do watch out for the next video. Okay. So thanks for watching, and this was my way to solve this particular problem. If you have any other method, you can do comment below, and if it's a PDF or a solution, you can email me. The email address is in the description. Thanks for watching. Bye bye.